Installing 460 volts 3-phase pumps in a lake is permissible, adhering to the National Electrical Code, or NEC, and ensuring the equipment is appropriately rated for the application. For electrical protection within the cupboard housing the fountain controls, several key components are essential. Firstly, a disconnecting means must be installed, rated for the voltage and current demands of the pumps. Secondly, overcurrent protection, such as circuit breakers or fuses, must be implemented and rated according to the ampacity of the conductor supplying the pumps. Thirdly, ground fault protection is required to detect and interrupt any ground faults, preventing electrical hazards. Finally, surge protection is recommended to protect the equipment from voltage spikes and surges. Special submersible cables can be installed in a lake without additional protection, provided they are specifically rated for submersible applications and installed in accordance with the NEC. Submersible projectors used in the fountain installation require special rock guards or lens guards to protect them from potential damage. Relevant NEC articles include Article 680, which covers swimming pools, fountains, and similar installations, providing comprehensive guidelines for these specific applications. Article 406 addresses receptacles, cord connectors, and attachment plugs pertaining to the receptacle used for the fountain pump. Article 300 outlines wiring methods applicable to the installation of submersible cables, ensuring safe and compliant wiring practices. Article 250 focuses on grounding requirements, essential for the proper grounding of the fountain to prevent electrical hazards. In addition to these NEC requirements, several recommendations should be considered. It is highly recommended to engage a licensed electrician for the installation to ensure compliance and safety. Use only materials that are specifically rated for the intended application, guaranteeing durability and reliability. Adhere strictly to the manufacturer's instructions for the installation and maintenance of the fountain, optimizing its performance and longevity. Regularly inspect the fountain and promptly address any necessary repairs, maintaining its functionality and safety. Article 680(26) covers equipotential bonding. This section mandates the creation of an equipotential bonding grid in and around the fountain to minimize voltage gradients and prevent electric shock hazards. All metal parts, including the fountain structure, pumps, and any metal within a specified distance of the fountain, must be bonded together using a solid copper conductor not smaller than 8 American wire gauge. This bonding grid ensures that all conductive surfaces are at approximately the same electrical potential, reducing the risk of electric shock to anyone in or near the water. Furthermore, underwater luminaires and lighting systems must comply with Article 680(27). This section outlines the requirements for submersible lighting fixtures, including their construction, installation, and wiring. Lighting fixtures must be specifically listed for underwater use and installed at a minimum depth below the water surface, as specified by the manufacturer. The wiring for underwater luminaires must be suitable for wet locations and installed in rigid metal conduit or liquid-tight flexible metal conduit. Additionally, a ground fault circuit interrupter, or GFCI, is required to protect the lighting circuit, providing an extra layer of safety against electrical shock. The location of the disconnecting means is crucial for safety and ease of maintenance, as detailed in Article 680(12). The disconnecting means for the fountain's electrical system must be readily accessible and located within sight of the fountain or be capable of being locked in the open position. This allows for quick and easy shutdown of the power supply in case of an emergency or during maintenance procedures. The disconnecting means must be clearly labeled to indicate its purpose and the equipment it controls. Proper selection and installation of conductors are vital for ensuring the safe and efficient operation of the fountain, as outlined in Article 310. Conductors must be selected based on their ampacity, voltage rating, and suitability for the environmental conditions. Submersible cables must be specifically listed for underwater use and resistant to water, chemicals, and mechanical damage. The conductors must be properly sized to carry the load current of the pumps and lighting systems, taking into account voltage drop and ambient temperature. Additionally, the conductors must be protected from overcurrent by circuit breakers or fuses, sized according to their ampacity. Grounding and bonding requirements are further elaborated in Article 250, providing detailed instructions for establishing a safe and effective grounding system. All metal parts of the fountain, including the structure, pumps, and enclosures, must be grounded to provide a low impedance path for fault current. The grounding conductor must be sized according to the size of the supply conductors and connected to a grounding electrode system such as a ground rod or grounding plate. Proper grounding ensures that any fault current will quickly trip the overcurrent protection device, minimizing the risk of electric shock. Surge protection devices, or SPDs, are highly recommended to protect the fountain's electrical equipment from voltage surges caused by lightning or other transient events, as described in Article 280. SPD should be installed at the main electrical panel and at any sub-panel supplying power to the fountain. The SPD must be rated for the voltage and current of the electrical system and have a low clamping voltage to effectively divert surge current away from sensitive equipment. Proper surge protection can significantly extend the lifespan of the fountain's electrical components and prevent costly repairs. The installation of ground fault circuit interrupters, or GFCIs, is essential for providing protection against electric shock in areas where water is present as mandated by Article 680(51). GFCIs must be installed to protect all receptacles and electrical equipment located within a specified distance of the fountain. GFCIs detect even small amounts of leakage current to ground and quickly interrupt the circuit, preventing electric shock. Regular testing of GFCIs is recommended to ensure they are functioning properly. Compliance with Article 110(3), which covers examination, installation, and use of equipment, is crucial for ensuring the safety and reliability of the fountain's electrical system. All electrical equipment must be carefully examined to ensure it is suitable for the intended use and installed according to the manufacturer's instructions. The equipment must be used within its rated voltage, current, and environmental conditions. Any damaged or defective equipment must be replaced immediately. Proper installation and use of equipment are essential for preventing electrical hazards and ensuring the long-term performance of the fountain. Furthermore, adherence to Article 314 concerning outlet boxes, conduit bodies, and handhole enclosures is vital for protecting electrical connections and ensuring their accessibility for maintenance. Outlet boxes and conduit bodies must be properly sized and installed to provide adequate space for conductors and prevent damage to the wiring. Handhole enclosures must be installed to provide access to underground wiring and equipment for inspection and maintenance. All enclosures must be suitable for the environmental conditions and protect the electrical connections from moisture, dirt, and physical damage. Regular inspections of the fountain's electrical system are essential for identifying and addressing any potential problems before they become hazardous, as recommended in Article 590. The inspection should include checking for damaged or deteriorated wiring, loose connections, corroded components, and any signs of water damage. The overcurrent protection devices and GFCIs should be tested to ensure they are functioning properly. Any necessary repairs or replacement should be performed promptly by a qualified electrician. Regular inspections can help prevent electrical hazards, extend the lifespan of the equipment, and ensure the safe and reliable operation of the fountain. When selecting submersible cables, it is important to ensure they meet the requirements outlined in Article 400, which covers flexible cords and cables. Submersible cables must be specifically listed for underwater use and resistant to water, chemicals, and mechanical damage. The cables must be properly sized to carry the load current of the pumps and lighting systems, taking into account voltage drop and ambient temperature. Additionally, the cables must be protected from overcurrent by circuit breakers or fuses, sized according to their ampacity. Proper selection and installation of submersible cables are essential for ensuring the safe and reliable operation of the fountain. Moreover, compliance with Article 350 regarding liquid-tight flexible metal conduit, or LFMC, is necessary when using this type of conduit for protecting wiring in wet locations. LFMC must be properly installed and supported to prevent damage to the conduit and wiring. Fittings used with LFMC must be liquid tight and suitable for the environmental conditions. NEC can provide a flexible and durable means of protecting wiring in areas where it is exposed to moisture or physical damage. The use of proper wiring methods, as detailed in Article 300, is crucial for ensuring the safety and reliability of the fountain's electrical system. Wiring methods must be selected based on the environmental conditions, voltage, and current requirements. Wiring must be properly supported and protected from physical damage. All electrical connections must be made in approved enclosures and secured with appropriate connectors. Proper wiring methods can help prevent electrical hazards and ensure the long-term performance of the fountain. Furthermore, adherence to Article 312 concerning cabinets, cutout boxes, and meter socket enclosures is vital for protecting electrical equipment and providing a safe working environment. Cabinets, cutout boxes, and meter socket enclosures must be properly sized and installed to provide adequate space for conductors and equipment. The enclosures must be suitable for the environmental conditions and protect the equipment from moisture, dirt, and physical damage. All enclosures must be securely mounted and properly grounded. Regular maintenance of the fountain's electrical system is essential for ensuring its continued safe and reliable operation, as recommended in Article 590. Maintenance should include cleaning electrical equipment, tightening connections, inspecting wiring for damage, and testing overcurrent protection devices and GFCIs. Any necessary repairs or replacement should be performed promptly by a qualified electrician. Regular maintenance can help prevent electrical hazards, extend the lifespan of the equipment, and ensure the safe and reliable operation of the fountain. When installing underwater lighting, it is important to comply with the requirements outlined in Article 411, which covers lighting systems operating at 30 volts or less. Lighting systems operating at 30 volts or less are considered intrinsically safe and can be installed in wet locations without additional protection. However, the power supply for these lighting systems must be properly grounded and protected from overcurrent. Additionally, the lighting fixtures must be specifically listed for underwater use and installed according to the manufacturer's instructions. The use of low-voltage lighting systems can provide a safe and energy-efficient means of illuminating the fountain. Furthermore, adherence to Article 314 concerning junction boxes is crucial for protecting electrical connections and ensuring their accessibility for maintenance. Junction boxes must be properly sized and installed to provide adequate space for conductors and prevent damage to the wiring. Junction boxes must be accessible for inspection and maintenance. All electrical connections must be made in approved enclosures and secured with appropriate connectors. Proper installation of junction boxes is essential for preventing electrical hazards and ensuring the long-term performance of the fountain. The use of proper grounding and bonding techniques, as detailed in Article 250, is critical for ensuring the safety of the fountain's electrical system. All metal parts of the fountain, including the structure, pumps, and enclosures, must be grounded to provide a low-impedance path for fault current. Bonding is used to connect different metal parts together to ensure they are at the same electrical potential. Proper grounding and bonding can help prevent electric shock hazards and ensure the safe operation of the fountain. Moreover, compliance with Article 430 regarding motors and motor circuits is necessary for ensuring the safe and reliable operation of the fountain's pumps. Motors must be properly sized and protected from overcurrent and overload. Motor circuits must be wired according to the NEC requirements and protected by circuit breakers or fuses. Regular maintenance of the motors, including lubrication and inspection of wiring, is essential for ensuring their long-term performance. The implementation of a comprehensive safety program is essential for protecting workers and the public from electrical hazards associated with the fountain, as recommended in Article 590. The safety program should include training on electrical safety, lockout-tagout procedures, and the use of personal protective equipment. Regular safety audits should be conducted to identify and address any potential hazards. A well-designed and implemented safety program can help prevent accidents and ensure the safe operation of the fountain. The selection and installation of electrical equipment in accordance with its listing and labeling, as required by Article 110(3), is crucial for ensuring its safe and reliable operation. Electrical equipment must be listed by a recognized testing laboratory, such as Underwriters Laboratories, and labeled with its voltage, current, and environmental ratings. The equipment must be installed according to the manufacturer's instructions and used within its rated parameters. Proper selection and installation of listed and labeled equipment are essential for preventing electrical hazards and ensuring the long-term performance of the fountain. The adherence to the requirements for working space around electrical equipment, as specified in Article 110(26), is vital for providing a safe working environment for electricians and maintenance personnel. Adequate working space must be provided around electrical equipment to allow for safe access for inspection, maintenance, and repairs. The working space must be clear of obstructions and properly illuminated. Compliance with the working space requirements can help prevent accidents and ensure the safety of electrical workers. Furthermore, the proper identification of electrical equipment, as required by Article 110(22), is essential for ensuring the safety of workers and preventing confusion during maintenance and repairs. Electrical equipment must be clearly labeled with its function, voltage, and current ratings. The labels must be durable and easily readable. Proper identification of electrical equipment can help prevent accidents and ensure the safe and efficient operation of the fountain.